Okay, thank you all for joining us here today to talk about running Amazon EC2 workloads at scale. My name is Boyd McGeechy. I'm a Senior Product Manager here in EC2, and I'm lucky enough to be joined today by Chad Schmutzer, a Principal Developer Advocate in the EC2 Spot Instances business. So today we've got a relatively packed agenda and a few demos that we want to get through, so we'll get stuck straight into it. We're going to learn about launch templates, EC2 Fleet, and then we're going to spend most of the time today talking about how you can use EC2 autoscaling to operate at scale in an efficient way. But before we jump into that, a little bit of a history lesson to sort of help understand why some of these tools exist and why they're so powerful. So at first, many years ago, decades ago now, I suppose, we launched EC2. And at the time, we launched a single instance creatively called the M1 Small. Then before long, we realized, well, you know what? A single instance size isn't going to be suitable for absolutely every type of workload. And then we got really creative and launched the M1 Medium and the M1 Large. What were they? They were M1 Medium was twice the size of the M1 Small, and the Large was twice the size of the Medium. And as hopefully all of you are very aware, we didn't stop innovating over a decade ago. We continue to add more and more instances based on customer feedback. So even back in 2017, we had over 70 different instance types. And obviously, we've continued to launch new instance types over the last couple of years, a few of those on the right-hand side here. We launched these instances in response to customers that wanted to bring different types of workloads that would be optimized potentially on different characteristics. So maybe you need more memory or more disk or a different type of disk, maybe SSD versus hard drive. And then, of course, as the underlying resources that are used to deliver servers, like the chipsets, continue to advance, we continue to launch more generations. So, the C5 is a compute-intensive instance, and the fifth generation of compute-intensive instances that we've launched. So not only were we launching new instance types, over the last decade plus years, we've launched multiple different purchase models to help customers optimize. So when we started, we had a business model called on-demand. On-demand pricing is now where you pay per the second. When you turn the server off, as little as a second later, we stop charging you for that workload. It's fantastic to get started. Obviously, very flexible, great for development and tests, spiky workloads. And as I say, pretty much everyone, when you're getting started with EC2, most people get started with on-demand. Then customers gave us feedback and they said, well, hey, if I'm going to keep using the server 24/7 for the next year or the next 3 years, because I'm not going to turn this thing off because maybe it's a database, I think I'd like to make a commitment to Amazon and then get a lower price than what you charge on-demand customers. And that's pretty much exactly what the reserved instance model offers customers. You can make a 1 or 3 year commitment to continue to use that instance type, to continue to use EC2, and we give you a really significant discount off the hourly rate versus on-demand. I think it's as much as 70% discount for purchasing a reserved instance. And then finally, something we'll spend a little bit of time talking about today, certainly, spot instances. And spot instances really were invented to help customers take advantage of our spare capacity. In order to deliver the elasticity you expect from on-demand and reserved instances, it's necessary that we have spare capacity available. And with spot instances, we've created an opportunity for customers to save up to 90% off the on-demand price when they take advantage of that spare capacity. It's fantastic for fault-tolerant, flexible or stateless workloads. Because it is our spare capacity, when we do need it back, we give you a 2-minute warning and we can take that instance back off you, but obviously up to 90% discount. So when we're talking about running at scale in an efficient way, you'll often hear us talk about combining purchase models to optimize. So for example, in a daily scale of a web app, you might find that there's a base load of work that you can purchase reserved instances for. And you can see that down the bottom. You might have 2 instances that are always on for your application. And then you might have a combination of both on-demand and spot to help you deal with those elastic periods where you might need more capacity, but you don't necessarily need it 24/7. And so when we talk to customers who are doing a really good job, they're combining all 3 of these purchase models together to implement a really cost-effective solution running at scale on EC2. And I'll also mention here, it's not something we're going to spend a long time on, but in case you haven't heard about it, another great tool in the tool belt these days is called on-demand capacity reservations. And that's where you can actually reserve capacity without making any long-term commitments. You can reserve capacity, as the name suggests, on demand when you require it, and you can cancel it. And just like an on-demand or a spot instance, when you turn it off or you cancel that on-demand capacity reservation, seconds later, we stop charging you. So really, we're going to talk a lot today about some of the tools that we've delivered and how you can leverage those tools to combine these different instance options that are available and the purchase models together to run efficiently at scale. And so here's an example of why you might want to do that. A very common thing we see customers do, sort of to what that previous graph showed, is you might have a base level of reserved instances, and then you'll turbo boost with spot instances. A very common use case. So you might have for 20 hours of the day, 10 instances satisfies you perfectly, but maybe during peak load, when there's a lot of people buying stuff or looking at your website and viewing the latest news or whatever it may be, for 4 hours a day, you might need another 20 instances. And so you might combine on-demand or reserved for that base 10 and spot for what you need only for those 4 hours. Similarly, while we have, well and truly over 70 different instance options, what some customers have told to us is, hey, I'm not really that specialized. While all of the options are great, and certainly some applications I need a very specific instance type, there are many applications out there where customers tell us, hey, I just want the cheapest vCPUs or the cheapest memory or the cheapest containers. And so again, some of the tools we're going to talk about today allow you to not select instances or not have to scale on the concept of number of instances, but instead you might scale on how many cores do you need, or how many gigabytes of memory do you need, or maybe you just need enough capacity to satisfy 1,000 containers, and you want to do it as cheap as possible. And so that's another reason why we're seeing customers use some of the tools we're talking about and combine instances and purchase models together. And then finally, the cloud is elastic. It's in the name of EC2, but certainly there are some times when customers might have really dramatic scaling requirements where you need to go from potentially 10 instances to 10,000 in a really rapid time period, scaling 1,000x almost immediately. And so what we see some customers do is, again, using the tools that Chad's going to demo for you today and that we're going to talk about in order to enable you to have backup instances. So, while most of the time, if you want to launch another 10, another 100 instances, the ideal instance that you want is going to be there. There could be rare scenarios where the absolute ideal instance, we just don't have enough. Maybe you need 10,000 and we only have 9,000. And so one of the things that customers are doing is they're combining maybe 2 or 3 different instance types to make sure, even in the most dramatic scaling events, they can always get the capacity they need with EC2. All right, so I spent a lot of time talking about the tools that we're going to be diving into today. Obviously, very excited we have Chad here to show you some specific demos, but let's quickly introduce them all. So first, we're going to talk about EC2 launch templates. Then we're going to talk about a primitive that we launched last year called EC2 Fleet. And then finally, we're going to talk about EC2 autoscaling groups. Hopefully, all of you have already heard about EC2 autoscaling groups, but today you might learn about some new functionality that we added toward the end of last year to EC2 autoscaling that really brings together combining instance types and purchase models as I've been discussing. So what are launch templates? Launch templates are a tool designed to help our customers increase productivity, simplify permissions and governance and best practice management, and also provide a consistent experience across APIs. You might be a customer who launches EC2 instances using a number of different APIs today. Launch templates is a way that you can unify that experience or provide a more consistent experience across APIs successfully. And obviously, launch templates are available today by CloudFormation, Autoscaling, and obviously EC2 Fleet as well. So what do I mean by increased productivity? A simple example, and this is by no means exhaustive, but a simple example is if you've ever had the issue of pushing out a new patched AMI to your customers. You might have maybe tens or hundreds of developers that are using your golden AMI, and you might update that based on the security patches or maybe some efficiency gains, whatever it may be. And so with launch templates, what you can actually do is just tell all of your users, use the default launch template. And then in the background, you can go and update the UMI that launch template refers to. And so all of your users don't need to change anything anymore. You don't even need to change the UMI ID. No work whatsoever. You continue to reference, this is my favorite launch template, use the default version, and then can be, one person or one team of central administrators that keep that launch template up to date. Similarly, tags is a really great way to not only give you insight into the cost, what's driving your usage and the costs associated with compute, but it's also a great method to sort of control access and do other aspects of governance as well. And one of the things customers gave us feedback on is it would be great if there was a way that I could ensure in a consistent manner that tags are always applied. And again, launch templates is a great way to do that. You can build into the launch template all of the core tags that you absolutely want every time one of your users launches an instance. They can add extra tags. There's nothing that's going to stop them doing that. But at least when you build in the tags into the launch template, you'll know that, hey, name, special server, owner, team A, that's going to be there every single time. And again, maybe you need to add a new tag for whatever reason. You can just go update the launch template just like before. As long as they're using the default version, no worries. They're just going to pick that up. No changes to the actual code or how your end users deploy. You can have a central person or central team manage that. And then finally, governance and permissions. I just really love this example. I love to share this with people because this gives you an idea of how you might previously, without launch templates, have to apply a very detailed policy on the rules. What is a customer allowed to do? They're allowed to launch into this subnet with this security group, with this key pair, with this snap, so on and so forth. And now you see on the right-hand side, you can just say this customer is allowed to use this specific launch template. And then you can build any governance and rules. What's the security group? What's the network interface? All of that you can build into the launch template. So not only does it make it much simpler to view and read, but let's say you wanted to make it change. Instead of having to go and change policies, potentially in multiple places or multiple times, you can just go update the launch template. Your users are using that launch template. That's the only way they're allowed to deploy. Bang, you're taking care of your auth in a much more simplified manner. All right, so now I'll hand over to Chad for a quick demo on launch templates.
All right, thanks, Boyd. So let's take a little closer look here at launch templates and how they work. So I've set up a quick demo here. So what I'm going to show you is basically a couple of things. First, very, very basic. Let's just launch an EC2 instance from the CLI, and we'll see. I can pass all of these parameters from the CLI, including things like my image ID, my subnet ID, my security group IDs, my instance types, my key names. It's perfectly fine to do, but it's a bit clunky to have to remember all of these parameters. But it does work, right? So I'll launch an instance here, right? If I head back to the console, let's take a look at this instance that I just launched. Right, so we see this instance is spinning up. It's in the pending state. But look, I forgot to give it a tag, right? So, best practices would be for me to tag things. So, some of the things that launch templates let you do are to enforce best practices, which would mean including tags in my launching instances. So let's try a couple of things here, right? So let's think about this. What if I have a user who we want to restrict permissions to, right? We don't want to give them full-blown administrator access. We want to enforce best practices. We want to make sure that they're following best practices and tagging everything, but we don't want to give them full administrator access. So let's look at how launch templates help solve this in two ways, right? It helps us templatize our parameters, but they also help us restrict permissions to allow users to only have permissions to certain things. So let's make, first let me show you this user trying to launch this without permissions, right? So I have a worker profile here. So I'm going to pass the worker profile into the CLI, and I'm going to show you that this user, this profile worker, this profile named worker doesn't actually have permissions to run the same command that I just previously run. So let's go ahead and make a launch template out of these parameters. So I'll head to the EC2 console. I'll click on Launch Templates, and I'll create a new launch template, and we'll simply call it Worker LT. Go ahead and take the parameters from this run that I just did and start to use them to populate my launch template. So we'll stick the AMI ID in here, the instance type. I love C3.extra large, my favorite instance type. I'll just click that. I'll click here, get my name in there, my key pair name in here. Down here in network interfaces, I'll go ahead and add a network interface. This is where I'll define the subnet and the security group. So let me go ahead and go back and grab that here. So we'll get subnet ID. And then we want to also populate the security group. Here we are. And finally, down here under instance tags, here's where we can go ahead and make sure that our launch templates are enforcing best practices. So we're doing live webinar demo for the name. And we'll go ahead and do create launch template. All right, so now we have a new launch template called Worker LT. So let me show you something else real quick here. Let me show you that this IAM user doesn't actually have permissions to anything except for the ability to execute on a parameter that has the launch template. So let me show you how this looks here. I have my user. My user's name is Worker. And this Worker does not belong to any groups. They have 0 permissions except for this single IAM policy that I have attached to it called Worker LT. Let's take a look at what this policy looks like. I'll just click Edit here. And this policy simply says, for the action EC2 run instances, I have a condition required that there is a launch template utilized, and that launch template belongs in my account, right? So I have permissions to call run instances as long as I've provided a launch template, and as well as I've given myself permissions to create tags on instances, right? So these are the only permissions that this user has, right? So let's go back and run the same command in a very simplified fashion here, right? We're still going to call with the profile worker. We're going to call run instances, but all we're going to do is pass the launch template instead of having to remember all of these configurations, and as well as without having any extra permissions except for the one that I just showed you. So let's go ahead and run that here from command line. We can see now I was able to execute this command using the launch template, and I've been able to spin up an EC2 instance. And if we go back to here, we can see that, in fact, this instance was spun up by this user, and it has the name of the tag that I provided in the launch template here. All right, so there we are, live webinar demo. My instance is spun up, and it was a C3 extra large. So there you go. So I've been able to do 2 things. I've been able to templatize my parameters for the run instances API, and I've also been to use launch templates as an authorization platform for calling that API. All right, so there's the demo. I'm going to turn it back to you, Boyd.
All right, thanks very much, Chad. Now let's dive into EC2 Fleet. EC2 Fleet is a scaling service or provisioning service designed to help customers request in a single API call across instance types, availability zones, and purchase models. And you know how customers can now begin to combine these purchase models and instance types in a single organized fashion to optimize and deploy at scale. So benefits, obviously, you can use this to reduce costs, whether that be combining spot instances with on-demand or RIs, or really even just reducing costs through those operational efficiency benefits that you might get. Whether you're deploying in a different region and you don't know what instances are available, well, you could put C3, C4, C5, and so long as one of them is available, Fleet's automatically going to find the capacity that's available and launch that for you. But the real idea behind EC2 Fleet, you know, the key features is this idea that it enables a flexible capacity allocation. And so really what I mean there is it's the API that is beginning to allow customers to define multiple different instance types, potentially multiple different subnets, and then pass responsibility to Fleet to optimize on your behalf. And we do that through this concept called allocation strategies. And so what does that mean, allocation strategies? Well, for on-demand, an allocation strategy in EC2 Fleet could be a prioritized list. So, try C5 first. And in most cases, C5 is going to be available. We're going to launch all the capacity you want on C5. But that scenario I talked about before, scaling to 1,000, well, you could put C4 as your second favorite instance type, or maybe M5 as your second favorite instance type, your second in the prioritized list. And then in the scenario when there wasn't enough C5, obviously it's going to be rare, but in that scenario, Fleet will automatically roll over and start launching additional capacity on C4 if necessary for you. For spot instances, most customers are using this concept called the lowest price mode. Spot prices can change. They change infrequently, but whatever's cheapest today may not necessarily be cheapest tomorrow. We don't want you to have to focus on that or continue to sort of query the spot market and learn what those prices are. You can just say to Fleet, hey, I'm willing to use the C3, the C4, and the C5. I need 1,000 cores. Just give me the cheapest option. Another thing you can do with this lowest price mode is actually say that I have 5 different instances that work for me, and I want to deploy across the 2 cheapest options. And so you can ensure that you don't put all of your instances in a single spot capacity market without necessarily deploying across all of them, all 5 options. So it gives you that flexibility to balance your availability requirements with your cost sensitivity. So you're totally in control with those allocation strategies. And certainly this is a place that you should continue to expect more innovation in how we can make intelligent provisioning decisions based on the flexibility you provide to EC2 Fleet. And then finally, as I said, not only can you provide us different instance types and then use these strategies to launch, here's a very simple look at what the API definition looks like, where you can say what you want your on-demand target capacity to be, what you want your spot target capacity to be, and then we'll go out and get that. Now, a very common question here, and I'm sure we're going to get it today, so I'm going to answer it immediately. We do not respond to capacity being unavailable in spot. So what I mean by that is if you request 10 on-demand target capacity and 5 spot target capacity, we'll launch the 10 on-demand instances, we'll launch the 5 spot instances. But if we can't get those 5 spot instances or some of those are taken away, we will not launch on-demand instances. So you can be sure that if you've asked for 5 spot instances, you're going to get spot pricing. We're not going to go and start launching on-demand instances and potentially charge you a lot more. And then finally, I wanted to talk about EC2 Fleet, the different types that are available. EC2 Fleet has 3 types. I'd really encourage you to focus on the one at the bottom here, Instant. But we'll go through all 3. So EC2 Fleet enables you to say, I want to do a type request. And really what that is we place all the bids. If you say, I want 100 instances, we will continue that fleet to be alive until we get those 100 instances up and running for you. Once those 100 instances are up, Fleet stops doing any work, okay? So we're not going to replace any instances that are taken away. You can't scale up or down. You can terminate instances. You can launch a new fleet, but you can't modify that existing request. Maintain mode is the default mode. Similar to the request mode, if you ask for 100, maintain mode is going to keep trying until it gets to 100 instances. However, unlike the request mode, you can modify a maintain request. So that means you can scale it up. If now you want 200, you can go to 200. You can scale it down to 10. So maintain mode enables you to scale up and down, as long as you'd like, and then cancel the fleet as well, and we can automatically terminate all those instances on your behalf. I'm most excited today to tell you a little bit more about the Instant type. This is the newest type of EC2 Fleet. It launched in November 2018. And Instant is actually where we see most customers adopting EC2 Fleet these days. Instant is an opportunity for you to say, I want to use EC2 Fleet with all of that ability to combine purchase models and instance types, but with the performance that you expect from a run instance API call. So what that means is it's a synchronous response. If you ask for 100, we will, in the API response, return the 100 different instance IDs and then stop doing any work. All right. Now that we've gone through some of those ideas, I'm going to pass it over to Chad, who's going to give you a demo of how you can actually use EC2 Fleet in instant mode.
Okay, thanks, Boyd. So for our next demo here, we're going to dive in here and take a closer look at EC2 Fleet. As Boyd has pointed out, EC2 Fleet is a very powerful API. And so let's take a look at using EC2 Fleet in detail. So first of all, I have a launch template that I've created for my EC2 Fleet. So let's take a look at what that looks like. This launch template here is very simple. It simply has the AMI ID and it has a tag inside of it. And so let's go ahead and create this launch template so that we can use it for our EC2 Fleet request. All right, so I'll go ahead and I will just simply run the create launch template command here from the CLI. Okay, so I've created a brand new launch template. I've had this returned here. Let's take a look here in the console under launch templates, and we can see that I just made this launch template and it's ready for us to use. It's called EC2 Fleet and it's ready to go. So now let's go take a look at the actual EC2 Fleet configuration here. All right, so I've got an EC2 Fleet configured, and I've got a couple of things that I'll point out here. All right, I've got at the top, I've got my spot options. So first of all, we can see I'm taking advantage of the allocation strategy called lowest price, coupled with the instance pools to use count, which I've set at 4. So what this means is, of all the capacity pools that I'm allowing EC2 Fleet to utilize, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 capacity pools. And remember, a capacity pool is a combination of an instance type and an availability zone. And the availability zones here are defined by the subnet IDs that I've provided. Of the 9 capacity pools that I'm allowing Spot Fleet to utilize, please use the 4 lowest priced. So what's going to happen is EC2 Fleet is going to look at of all 9 pools, which are the 4 cheapest, and it will concentrate and diversify my instances across the 4 cheapest pools, right? So I have the best of both worlds. I've been able to diversify across my instance pools, but I've also told it to target the lowest of all of them. And in case one of the pools happen to become constrained, EC2 Fleet is welcome to tap into any of the other pools that it needs to fulfill the ultimate capacity request. Down here at the bottom, we'll take a look here. What we're going to ask for here is an EC2 Fleet of type instant, right? And what this means is that EC2 Fleet is going to become a synchronous call for capacity. It's going to say, please give me the capacity, please fulfill the capacity, and give me a synchronous response whether you can or cannot. And if it can, it will return the instance IDs to me immediately so like I can immediately start to use them. If it can't, it will time out, and then I'll know that this EC2 Fleet itself wasn't able, this request wasn't able to be fulfilled. I'm also tagging here, in addition to the other parameters, I'm also providing some flags here for the tag. And I'm definitely asking for only spot instances in this EC2 Fleet request. All right, so let's go ahead and shoot for the stars here. I'm going to ask for 100 instances in this EC2 Fleet request. I will save that, and let's head over back to my demo here, and we'll go ahead and actually call EC2 Fleet create EC2 create fleet from the CLI and watch the magic happen. All right, so remember, we're asking for 100 instances of an EC2 flight of type instant. So what should happen here is that we should get an immediate response whether we're going to get 100 instances, and here we go, right? So we've gotten a nice variety of instances that have been diversified across the 4 lowest price pools, and we see that EC2 Fleet did a pretty neat job of doing that here. We've got C3 larges in this subnet ID. We've got these spot instances from here. We've then got a selection of spot instances from this C4 large and this subnet ID, as well as C4 larges from this subnet ID, and then finally C3 larges from this subnet ID. So there are those 4 pools that we've allowed the EC2 Fleet to diversify across. Let's head over to the console and just do a quick refresh here of the instances that are running. Let's look for instances in the running state. You can see here we've got our instances that have spun up, and sorry, let me filter on instance state. Running. There we are. So we filtered. These are the 100 instances that were fulfilled from the EC2 Fleet request. We can see that we have the fleet ID description here in the description, and we have the launch template that was utilized to request these instances. So again, a synchronous response, very powerful tool, and there we go. So I'll turn it back over to you, Boyd, for the next part of our webinar.
All right, thank you very much, Chad. We're going to talk a little bit about EC2 autoscaling now, and we'll go through that. And then if you're beginning to wonder, and I'm sure some of you are, you're beginning to wonder, well, when do I select EC2 Fleet versus autoscaling groups? That's absolutely something we're going to talk about in just a moment. But first, let me introduce EC2 autoscaling groups and the new functionality that we launched last year to bring all of this together. So if you had have wanted to achieve what we've been discussing today before we launched the functionality of mixed instance policies in autoscaling groups in November 2018, this is sort of what you would have had to look at doing. You would have had to have an autoscaling group for C4 large on-demand instances. You would have needed a separate autoscaling group for your M5 large spot instances. And if you wanted another spot instance type, as we recommend whenever you're using spot, you should always be using more than one instance type in your fleet or autoscaling group. You would have had to have a third autoscaling group for your M4 larges. So here you see, obviously, to combine on-demand and spot, you'd inherently need two. And then to follow those spot best practices, you'd need at least two of them as well. So at least 3 autoscaling groups just to begin following spot best practices. Now with the launch of mixed instance policies, I'm very excited to say this can all be a single autoscaling group. So why would you use it? Well, just like Fleet, you can combine on-demand and spot instances now in a single autoscaling group, and you can use that to turbo boost, save up to 90%. Or, as we discussed, you could use it to scale 1,000x and have those backup on-demand instance types that we talked about. And certainly something that we are looking at adding very soon is the ability to scale in vCPUs or memories or containers, as we talked about earlier as well. So all of that is coming to autoscaling groups in the near future. And again, here's a quick look. If you look down at the instance distribution part of this code there, you'll probably see that it looks relatively similar to what you saw in EC2 Fleet. Autoscaling does use EC2 Fleet in order to achieve this. You don't need to be aware of that. You don't need to become an EC2 Fleet expert. If you just want to use autoscaling groups, you never need to learn anything about EC2 Fleet. But we just wanted you to know about all of these options. And so you can see here, we're saying for on-demand allocation strategy, we're going to do prioritized. So that's as we discussed. We're going to try C5 large first for on-demand launches, and only if there isn't enough C5 larges would we move on to the C4 large. So we've said we want an on-demand base capacity of 10, and then on-demand percentage above base capacity of 50. And then finally, for the spot allocation strategy, we're going to do lowest price, and we're going to use at least 2 instance pools. So what does this all mean? How is it actually going to work? Let's sort of walk through this briefly. So, here we have the same scenario we just talked about. We've requested a base capacity of 10 and an on-demand percentage above base capacity of 50. So if we set the desired capacity for that autoscaling group as 5, we're just going to launch 5 on-demand instances, because remember, we said the base capacity is 10 for on-demand. Okay, so now if we set the desired to the base, 10, again, what you see here is we have 10 on-demand instances. No spot instances launched yet because we said the base capacity of on-demand needs to be 10. Okay, now let's scale beyond 10, right? So now our desired capacity is 20. Well, hopefully you can think through what's going to happen here. We have the base of 10, and then we've said we want 50% of the capacity above base to be on demand. So We were asking for 20, 10's the base, so we've got 10 left over, and half of it, 50%, needs to be on demand, and so half of it's spot. And so that's how we end up with 15 on-demand instances and 5 spot instances there as well. Some quick recommendations on mixed instance policies. As I said, we always recommend at least 2 different instance types in an auto-scaling group using mixed instance policies. In fact, it's required. I actually recommend putting as many instances that work for your application as possible. For the on-demand, obviously, we're going to do it in your prioritized list. And for the spot instance requests, we're going to automatically select the cheapest options. So the more options you give us, the cheaper options we potentially can find. And obviously for on-demand, we're only going to ever use your number 1 priority unless we simply can't get enough capacity from it. We recommend diversifying across at least 2 spot instance pools. So this is a spot best practice. That's not necessarily what we're here to learn about today, but something we absolutely recommend for spot is that you use more than a single capacity pool, more than a single instance type, so that you don't lose all of your spot instances at once. Interruptions are relatively rare. Over 95% of spot instances customers actually turn off themselves when they've done their work. They turn them off. So interruptions are not necessarily all that frequent, but we always recommend to diversify across more than one spot instance type to ensure if we do happen to come and take your spot capacity back, you don't lose all of that spot capacity at once. Choose instance types of the same size across families. This is particularly powerful if you're running a web service. And then also just use the default max price for spot. What that means is we'll never charge you more than on demand. You don't need to think about a max price. You don't really need to think about anything. Spot prices normally fluctuate between a 70 to 90% discount. And if you don't set a max price, as I said, we promise we will never charge you more than on demand. That is the worst case scenario, while most of the time you're going to be saving 70 to 90%. And so now a little bit about how auto-scaling actually works and distributes your instances when you deploy. So auto-scaling groups has functionality where they will always try and ensure that capacity is balanced across availability zones. If a launch failure does occur, auto-scaling has an ability to retarget launches in different availability zones if the capacity isn't available. However, when we do this, we consider spot and on-demand separately. And so, for example, if there weren't enough spot instances in a single AZ, we would rebalance the spot instances while leaving the on-demand capacity balanced. So let me quickly just show you some quick pictures of how that exactly works. So here we had the optimal setup. Our spot instances and our on-demand instances were both evenly balanced across AZs. Let's imagine that we lost the spot instances in availability zone 1 on the left here. Auto-scaling groups could retarget those instances to the other AZ. And then auto-scaling will continue to try and see if it can relaunch capacity in availability zone 1 so that it can get back to being balanced. And if and when it's able to get those spot instances back up and running in availability zone 1, that's exactly what it'll do. It'll go back into this balanced state. So before we jump into the demo, I quickly want to touch on when should I use auto-scaling or EC2 Fleet? And the answer is in almost every scenario, if you want a system that scales and manages your instances on your behalf, the answer is EC2 auto-scaling groups. They have all of the functionality we've been talking about to combine instance types and purchase models there. And so if you're wondering what should I get started with, I highly recommend EC2 auto-scaling. So the fair question might be, well, when should I use EC2 Fleet? And the answer is, if you're operating a service or building an application that for whatever reason you don't want that ongoing scaling and management, and it doesn't necessarily mean scaling up and down, by the way. Auto-scaling can just be used to keep a cluster static and replace any instances that die. So it's not just about necessarily scaling up and down, but it's about maintaining and managing that capacity. If you don't want that functionality, then use EC2 Fleet in instant mode. That's the example the demo Chad gave earlier. If you find yourself using EC2 Fleet in request or maintain mode, I really do encourage you to go back and consider if there's not a good reason why you're not using EC2 auto-scaling instead. So to try and keep it simple, start with EC2 auto-scaling. If that doesn't work because you don't like the powerful management functionality that it gives you, then you might like the provision-only mode of EC2 Fleet, the instant mode that Chad did the demo on earlier. And so with that, I'll hand over to Chad.
Okay, thanks, Boyd. So let's take a little closer look at how we can utilize EC2 auto-scaling groups to really deploy our workloads at scale. So what we'll do in this here is we're going to take a look at an ASG config, right? An EC2 auto-scaling group config that we're going to use based on what Boyd just talked about here. So what we've done is we've defined an EC2 auto-scaling group configuration in this JSON config, and we're going to utilize the mixed instances policy for this EC2 auto-scaling group. Now remember, we had already created an EC2 Fleet launch template in our previous demo, so I'm going to simply reuse this launch template, right? There's no reason to create a new launch template because the whole point of using launch templates is to templatize your configuration parameters, right? So the things that are referenced in the launch template that we created earlier can be reused for my EC2 auto-scaling group as well. And what we're going to do is take advantage of what are called overrides to add additional instance types to my EC2 auto-scaling group request. So in this case, I'm actually going to tell my auto-scaling group that I can use any of these instance types. So I have the C3, C4, C5 large, M3, M4, M5 large, and R3, R4, R5 large. And so we're going to allow in this case, the EC2 auto-scaling group to diversify across the five pools in each AZ. So what we're going to do is allow it to find the lowest price pools and the 5 lowest price pools in each availability zone. And down here, we're telling the EC2 auto-scaling group which availability zones it can look into for capacity. So I've got 6 different AZs listed here in my region in US East 1, because again, these are defined by subnet IDs. So here, up here in the instances distribution section, I have a baseline of 10 instances requested for, excuse me, for my EC2 auto-scaling group request. So that means the first 10 instances will be on demand, and everything above that will be spot, because I've set everything above the base capacity to percentage to be 0, which means the rest of it will be fulfilled with spot. So in this case, I'm setting a min size of 10, a max size of 125, and I have a desired capacity of 75. So what this means is it will spin up 75 instances. The first 10 will be on demand, and the remaining 65 will be spot. And anything that we scale above that, all the way up to 125, will also be spot, because we've set on-demand percentage above the base set to 0. All right, so let's go ahead and launch this auto-scaling EC2 auto-scaling group here from the CLI. Let's take this parameter. Go ahead and launch this. So this API actually doesn't return anything if it executed correctly. So I can head over to the console, take a look at my newly launched auto-scaling group. Okay, so we can see we have our auto-scaling group has been created. We can see it's set just as we described in the config. And if we take a look here at instances, we can see that here we go. The auto-scaling group is spinning up our instances in the desire in the fashion that we requested. Excuse me, and we can see that it's going to request 75 of those instances. So we can also see these through. Excuse me. Also see these through the EC2 instances console. Right, and if we filter on auto-scaling group, there we are. We can see that these are the instances that were deployed as a part of the EC2 auto-scaling group. And again, they're also referencing the same launch template ID. All right, well, that's it for my demo. I hope you were able to take away something from this last demo as well. And I'm going to turn it back to you, Boyd, for the rest of the webinar.
All right. Thank you, Chad. Nothing much else for the presentation to discuss, but obviously we've got 10, 15 minutes here to answer some of the questions live, some of the more frequent questions. And obviously, please continue to send in those questions if you've got them. We'll keep answering for the next 10, 15 minutes here.